Next up is number 20, the same deal. Limit as n approaches infinity of the absolute value. And again, you have to separate factorial is n times n minus 1 times n minus 2, and the list goes on. 3, 2, 1. But when I say a sub n plus 1, you really want to be cautious by replacing n by n plus 1. There's a big difference between those two. And here, the whole thing is squared, factorial, and you're replacing n by n plus 1. Divided or multiplied by the reciprocal. So just work slowly and you should be fine. The limit as n approaches infinity. If I really look at the top, that's actually 2n plus 2 because you distribute that n. Factorial. And this is n plus 1 factorial, the whole thing squared, multiplied by n factorial squared over 2n factorial. So, this is the limit as n approaches infinity of, and let's see how this plays. I know those two should connect somehow. So this is 2n factorial. I start reducing this. I'll say that is 2n plus 2, subtract 1. 2n plus 1, subtract 1. 2n, you could stop there because that matches. And here I want n factorial squared. Well, isn't this n plus 1 times n factorial? And if I'm raising, you know what? Why am I writing so small? Okay. Love it when technology doesn't do what it's supposed to move. Isn't this n plus 1 times n factorial squared? So if I distribute the squared, wouldn't that be n plus 1 squared times n factorial squared? And now I know those two cancel out, and I know those two cancel out. And what am I left with? The limit as n approaches infinity. Now, I could cut it a bit by factoring a 2 out of this. Or not a big deal, divide by the highest power term of the denominator and things will work out really smoothly. N plus 1 squared. Wouldn't this cancel one of those? By L'Hopital, since that's infinity over infinity, the derivative of the top is 4 and the bottom is a 1. Bigger than 1. Therefore, absolute divergent. Divergent by the ratio test. A really nice test, not that hard, very easy to use. This is another form of factorial, something we're going to develop in the second half of this chapter. This is called binomial. Keep in mind, this is a form of factorial, but it's not your traditional. Plus, they didn't give us the general term. We could find it. We're smart. Add 3, and add 3. The top is arithmetic. And the sequence is the very first term plus n minus 1 times the common difference. So that's 3n minus 1. The denominator is adding 2 every time. That is arithmetic as well. This is going to be the first term plus n minus 1. The common difference in this case is a 2. So that's 2n plus 1. So this is continuing. This plus should be right there. So for example, if I say let n equal 3, put a 3 there. 3 times 3 is 9 minus 1. That is 8 times 5 times 2. That's really what that is. Over. Put a 3 there. 3 times 2 is 6 plus 1. That's 7. Subtract 2 and subtract 2. You start with 3 and 2, and you're going to always run down that way. This is a form of factorial. A different form of factorial. Now you'll notice, now that we explained this, you'll notice, since it is factorial, just writing the first step is the busy work. What's a sub n plus 1? Well, a sub n plus 1 is 2 times 5 times 8 times 11. You know what? I should have put this better. I should have wrote it nicer. I have a lot of space here. I should have wrote it this way so you can see it better. Let me take this and move it down. So the general term really looks like this. And the denominator, the general term looks like this. There. So when you let n equal a value, let n equal whatever that is, you're going to multiply from 2 until you reach that. And here from 3. So it's lacking. This is lacking the 1, the 3, lacking a few terms. This is lacking the 2, the 4, the 6, the 8. Otherwise it will become a factorial. But it's a form of factorial, but you can't slap the factorial on it because factorial is defined in a specific one term at a time. So when I say a sub n plus 1, it's going to be all of those, right? And the next term, replace n by n plus 1. And the denominator is literally all of those. Times, love that part, the 3 dots. Times 2n plus 1, and the next term, replace n by n plus 1. So for example, if I say find this term, do you see that this is the previous terms and you just add one more? If I say find the next term, wouldn't you take literally what this is and just add one term to that? So take whatever this is and add a term. Now when you multiply by the reciprocal of this, you'll notice something really nice happens. All of these are multiplied, so all of them will cancel out. So the hard part is just understanding what this means and the very first step. Because since all of these are multiplied, I could simply cancel all of these with all of these and all of these with all of these. I'm left with the limit as n approaches infinity of, this is 3n plus 3 minus 1 over 2n plus 2 plus 1 is 3 by L'Hopital. This is the limit as n approaches infinity of 3 over 2, which is 3 over 2, but that's bigger than 1, therefore diverge by the ratio test. Alright? Do remember that the root test works the same way. So when I glance at this now, the fact that I see that this is raised to the n and this is, again, they don't specify. In general, they say, does this series converge or diverge? You have to figure out which test to use. If you could see that algebraically, you could write this as negative 2 over n to the n, then that's an easy call for which test to use. And in this case, yes, the root test will definitely work. But the ratio test will definitely work, but the root test is a lot more efficient. So what that does, that will eliminate the power completely. And that is 0 less than 1, therefore absolutely convergent by ratio test. There you go. A freebie. Did I say ratio test? I meant root test. Well, how would I know? I wouldn't be able to know. You write RT for both of those, and that's that. And here, do you see that this is raised to the n power? So there is a benefit in me using the root test. If I take the nth root and write that as negative 2n over n plus 1 fifth power, all raised to the n power, well, those cancel out in absolute value. That's going to be the limit as n approaches infinity of the absolute value of, and how does this work? That is negative 2 over 1 plus 1 over n, all raised to the fifth power. That's going to be 0. That will be negative 2 to the fifth power, but an absolute value, which is 32, bigger than 1. Therefore, diverge by the ratio test. Did I say ratio test? I meant root test. It's getting old, right? Same deal here. If I take the limit as n approaches infinity of the nth root of the arctangent of n, well, I noticed that the n's cancel out. The limit as n approaches infinity of arctangent of n is pi over 2. 3.14 divided by 2 is bigger than 1, therefore diverge by the ratio test. A root test. Keep the same. I'm so stuck on the ratio. Alright, I recopied definition 2 right there. It says a series is called conditionally convergent. Conditionally convergent. If it converges, if the series converge. But not absolutely. And the series of the absolute value diverge. Both of those must happen. For a series to be conditionally convergent, the original series, the series as is, must converge. But not absolutely. And the series of the absolute value must diverge. So, I would start with this if I was you. It's up to you. I'm looking at problem number 32 because if this converge, it's absolutely convergent and I'm done. If it diverges, then I have to do that part. So I look at this and use any test you like to determine whether this is absolutely convergent, conditionally convergent, or divergent. Well, if I take the limit as n approaches infinity of what? Do you see that's raised to the n? Wouldn't it be wise to use the root test? That's the limit as n approaches infinity of 1 minus n over 1 plus 3n in absolute value. That is infinity over infinity. I could use L'Hopital. I could divide by the highest power term of the denominator. Whatever makes you happy. You know what? Yeah, since it's only once, probably it's faster that way. That is negative 1 over 3, which is 1/3 less than 1. Therefore, absolutely convergent by the root test. I was going to say ratio. And how about this problem? I'm glancing at this problem, trying to figure out how this works. And I'm thinking, well, if I take the limit as n approaches infinity of n plus 1 times 5 to the 2 into n plus 1 over 10 to the n plus 1 plus 1 divided by, so I multiply by the reciprocal right away. Remember, I want to cancel those. That's the limit as n approaches infinity. So, to match n, 5 to the 2n over 10 to the n plus 1. I could say this is 10 to the n plus 1 times 10 to the 1. You could do this a few different ways. N plus 1, I'll leave it alone. And if you distribute that in, wouldn't you say that's 5 to the 2n times 5 to the second? This cancels that, and this cancels that. Pretty good. I'm left with the limit as n approaches infinity of 25n plus 1 over 10n, infinity over infinity, by L'Hopital, limit as n approaches infinity of 25 over 10. That is bigger than 1. Therefore, diverge by the ratio test. So, what does that mean? That means, therefore, what diverged by the ratio test? Therefore, the series, either the series is absolutely convergent or the series is divergent. And do you see that means that's an exception right there? And since the absolute value doesn't change that series right there, there's no way it could be conditionally convergent, because the absolute value and the non-absolute value will yield the same result, same values. So again, you know what, I'll explain that a bit in the next video. The next video, we only have 2 problems left, but I'm out of time. You know how it is. I just have to do those 2 problems and we're done. So the next video is going to be short. Just bear with it.